Hi guys, this video is about multi-threaded programming in Python. Let us see what is multi-threading. Multi-threading means the ability of a program to run in multiple threads simultaneously or concurrently. It allows the program to do more than one thing at once. So this is useful when dealing with large amounts of data or complex operations, where those can be break down into smaller tasks and each task can be handled by the threads. In Python, we have a built-in support for multithreading, and it is making it an ideal language for developing applications that require high performance and scalability. So when we are talking about high performance and scalability, then that means that is achieved through multi-threading concept only. So let us understand what is the difference between threading versus multiprocessing. See, where it is used, based on that we can distinguish between threading and multiprocessing. Threading is used for I/O bound task, which means input-output task, such as network request or file request. More than one file to be accessed means we can go for threading. But whereas multiprocessing is focusing on CPU bound task. Threading is focusing on I/O bound task and multiprocessing is focusing on CPU bound task. So what do you mean by CPU bound task? Means it involves mathematical computations which is required in image processing. So let us understand what is a thread. So a thread is an independent piece of code. It can perform a specific task. And it is the smallest unit of program that executes at particular point of time. Thread is a separate flow of execution within a program. So each thread will run independent of others, but they will share the same memory space, allowing them to communicate and exchange data. So thread is considered as an independent piece of code that can perform specific task. So this thread comprises of some information, and all these informations are present in a TCB, that is thread control board. So what does this thread control board have? It consists of several components. So first is thread identifier. Each thread is given an ID that is called as a thread identifier, and it is having a program counter, and its state is mentioned as thread state and thread register set and etc. So we need to understand the difference between process and a thread. See, process takes more time to terminate. Thread takes less time to terminate. Then process takes more time for creation, and here it takes only less time for creation. And process takes more time for context switching, that is switching from one process to another. Thread takes less time for context switching. Process is less efficient in terms of communication, but thread is more efficient in terms of communication. Not only that, process is isolated, but whereas threads will share the memory. Process is called as a heavyweight process, and thread is called as a lightweight process because it is sharing the code, data and resources. Here this process switching will use the interface in the operating system, but this thread switching does not require any call to the operating system, and it will not cause an interrupt to the kernel, that is your operating system. It has its process as its own process control block and the address space, whereas the thread has its parent's process control block, and it is having its own thread control block as I already told you, and it will share the common address space. So there are two types of threads. One is called kernel thread and another is called user thread. Kernel thread means these threads are part of your operating system. User thread means that is implemented by the user and as well as by the kernel. So we have various methods available in the thread class which we will be using In order to start the thread, we'll be using start and run and join. Join means we can combine more than one threads at a time. And to check whether the thread is active or not, we'll use isAlive. And to get the name of a thread, we'll use getName. And to set the name of a thread, we'll use this setName. So how do we create a thread? So there are two methods through which you can create a thread. The first method is using a threading module. So you have to import that threading module. Then in the second step, you have to define a function that will run in the new thread. So what the thread is supposed to do will be defined in this function. Then you have to instantiate or create a new thread object. Then through this thread object, you will call the method that is start to begin the execution. So these are the steps to create a thread. So import the threading module, you define a function, instantiate an object, then you have to call the start method. So now let us see with that example. So first, as I told you, you have to import a threading module. So this is what it means. Import threading. Then you have to define a function that will tell you what the thread is supposed to do. So you know that we'll be using diff, and this is my function name, my threads, and these are my parameters. And here what I am doing is I am just printing some I value which is ranging from x to y with the increment of 2. Okay, I am printing the name comma I. That is, name is a parameter which is passed to this function. So this is the function I have defined. Now next, third step is you have to instantiate an object. So how do I instantiate? T1 is equal to threading dot thread, where I will be passing the parameters for the function. So the first parameter will tell me which function I should refer. So my target function is, the name of this function is my thread. So you need to write my threads. Then the second parameter, you need to pass the arguments by using this args equal to. So these are some default variables you need to use. And I need to pass three parameters. The first parameter is x is assigned as 1, y is assigned as 10, and the name is nothing but referring to the thread name. So thread 1, like that. Then I will initiate the start method. Okay, so t1 dot start. So import the threading module, define the function, then instantiate the threading object, and then call the start function. So if I call this function, then this for loop will be executed, where it will print the name and the I. So you will get the output as thread 1, 1, 3, 5, 7, and 9. So this will be your output. The second method is how you can create a thread is using a class. So you have to create a Python threads using the class. Then how do you create the thread class means that class will be the subclass of the thread class. Then you have to override the init function, and then you can override the run method to define the behavior of the thread. And also you have to start method, call the start method. So let us see, we'll be looking into two examples. So first example is creating the subclass of the thread class, then overriding the run method and calling the start method. Another function will use, example will use overriding the init function and the run method. So let me take the first one. So first what you need to do is, as seen before, you have to import your threading module. Okay, that is more important. Then you will be importing the time, and then class. This is your name of the function. Okay, so that is the class subclass name, that is thread method. And this is subclass means it is the parent class is threading dot thread. Okay, so it is the parent class of this class. And then you will be defining a function called run. So there you can write any functions you want. So first, for simplicity, we are written for I in range of 10, print I. So which will print from 0 to 9. Okay, then I am just, after printing one value, we are just setting the timer to delay the process of the next call. So we'll be using time dot sleep of 2. Okay, so you can set if you make use of different values, that is which is larger than 2, that there will be a delay in printing this value. That's it. So after defining this class, I need to create an object for this class. So how do I create the object? This is the class name. You have to write and give a open bracket and close bracket and assign it to a variable, that is my object variable. And with this object variable, I will be calling the function start. So if I use this start, automatically this function will be executed. So you will be getting the values like 0 to 9, as I said. So here we have used a subclass. Okay, subclass is thread method and my parent class is threading.thread. Okay, so these are the default parent class which we are using. Now in the second example, I will show you creating a subclass by overriding the init method and as well as overriding the run method. So this is that example. So import threading. So as usual, you have to import the threading module and you have class thread. That is, this thread is a subclass and this is the parent class. Okay, and here I have written a function init. Init is nothing but a constructor. Okay, so whenever an object is created, this function will be called. So here what I am doing is, this function is having self, thread name, thread ID. Okay, so here I am just overriding by writing threading.thread.init self. And whatever is passed during the constructor. So when you construct an object, you will be passing some parameters, means that parameter will be copied here. So here it expects two parameters. Self is a default parameter. It is expecting a thread name and the thread ID. So you will be that thread name will be copied as the instance variable, that is your thread name, and thread ID will be copied to self.thread ID. So within the class, it will be these variables are visible. Now I'm just writing the run function, and where I will be writing simply that thread name and the thread ID, that I am printing it. That's it. So I am just converting that string variable as self.thread name, and I'm just giving a space. So plus means it will just combine and write all the variables. So thread ID may be in integer, so I am just converting into a string, and that is what is written. Okay, so now next step is I have to create an object for this class. So how do I create? Again, use the class name, and since it is having the constructor with two parameters, I need to pass two parameters. So I have passed the thread name as GFG and the thread ID as 1000. Okay, so thread 1 is the object variable. Thread 1 dot start will be your start method, initiation of your thread. That's it. Okay, so it will print exit. So you can see the output as CFG 1000 exit. So this is the two ways you can create the thread. So now what do you mean by multi-threaded program? Means the main thread will start several new threads and those threads are executed in parallel. So a program can have any number of threads and each will work on the same data. Now we'll see an example. Now here I have written two functions. Okay. So first I am using this, importing this threading module. Then I am writing two functions. So the first function is fun1, where I will be passing three values, that is yes, name and n, and I am using this for loop to print the name comma I. It is very similar to the previous example, and I am also writing fun2. Now you can see here I have included this as time dot sleep of 2, which means that it will delay the process for so many milliseconds. Okay, so here the same function I have written. Now this function will be executed by thread 1, that is fun1 will be executed by thread 1 and fun2 will be executed by thread 2. So that is why I have written two functions separately. Now we'll see how this two threads will be created. Means first you have to instantiate the object. So how do I instantiate? You need to write threading dot thread, and I told you it will have two parameters. One is the target equal to, you have to give the function name, so that is one. And arguments are, you have three arguments here, so I'll be passing for the first function I'll be passing 1 comma 10. So 1 comma name is thread1 and n is your 10. Okay, so for the range I'll be using the first value and the last value. Okay, so start value and the end value and the incrementing value. Okay, so similarly I'm creating this second thread by just changing the target function name as fun2. That's it. Okay, so other parameters are 0 and 10 I am passing. Here I am passing 1 comma 10 and here I am passing 0 comma 10. So we have created two thread objects, that is T1 and T2. Then we will be executing the thread by calling the start method. So T1 dot start, T2 dot start. So what will happen is these functions will be parallelly called. Okay, so T1 will be calling this function and T2 will be executing this function, and both will happen parallelly. And depending on the sleep, that is sleep means after printing this it will take some time to again execute this for loop. Okay, so here I have given the sleep time as 2 and here it is 1, which means that this function will execute. After that this function will be executing. So you can see the output here. So you can have the output as initially thread 1, thread 2 and 10, and then thread 2 is executing 2 and thread 1 is executing 3 and it is executing 4, like that. So parallelly, see, you can see you won't get, when you're executing this program, the same kind of result. Okay, so that at that moment which thread will be executed will be decided and both will be executing parallelly. Okay, so the same example using class, as I told you, you have to create a subclass and then instantiate the object and you have to call the start method. Okay, so that is also possible in the multiple threading, where here you need to create two subclass. Okay, so one is thread A and another is thread B, and your the parent class is threading.thread for both of this, and here I am defining a function and here another the function, that is run, and the same logic what we have seen here, seen in the previous example, we are using it. Okay, then you create an object for thread A, create an object for thread B, and that is T1 and T2, and you have to call this T1 dot start and T2 dot start, where you will be getting the same type of outputs. Okay, so now why do we go for multi-threading? The first advantage is it allows multiple operations to perform at once. It will save time because multiple operations are executed simultaneously. Definitely the time will be saved, and the threads are also independent of each other. So the benefits of multi-threaded programming will be resource sharing. So all the threads will share the resources such as memory, data and the files, etc. Okay, and it is more economical because they are sharing the resources. So each one may not require independent resources, they are sharing the resources, so it is more economical, and it fully utilizes the multiprocessor architecture. Multiprocessor means you will be having multiple processes present in the system, so each thread can be executed by each processor, so that simultaneously the execution will happen, which will reduces the time. And responsiveness in the other sense, even if a particular part of the thread is blocked, then it won't halt the entire program. Okay, so that is what is meant by responsiveness. Now, when we use multiple threads, then it is important to ensure that they should not interfere with each other. So that is where the synchronization comes into picture. So we need the coordination of the multiple threads to ensure that they access the shared resources in a safe and controlled manner. One should not interfere with another. So the coordination between the threads should happen when they are accessing the resources. So concurrent threads will simultaneously accessing the program. That program segment is called as a critical section. See, when thread 1 is accessing this resource, thread 2 is also simultaneously accessing the same resource or same part of the area. Then there will be some collision. Collision means they will collide with each other. So this should not happen. So how do we avoid that? So we can use semaphores. So semaphores means you have to import the threading, and in this threading module we have a method called semaphore. Okay, so use that method. And now how do we use that semaphore means before accessing this area, that is before doing some operation, you have to gain the authentication, and when once your job is over, then you have to release it. So we have defined one function one, and here what we are doing is using this semaphore, you call the method acquire. Acquire means when this thread is using this, when performing this operation, no other thread will interfere with that. So once the operation is over, it has to release it. That's it. So now similarly in this function 2, you have to write s dot acquire, and we can perform the operation, and after once the operation is performed, you have to release that. And and the same process. Okay, so you have to create a threading dot thread, and your target is equal to fun1. Here we don't have any argument, so we didn't use that second parameter args. And then you start the thread, and then threading dot thread target is equal to fun2 t2 dot start. So one thread will not interfere with the other by means of this semaphore process, and you will be getting the output like this. So you have 1 1, then 2, and then 1 1 1. Why this 2 is delayed means you can see this sleep value, we have given as 5. Okay, so that's why it is delaying. Now another way you can handle this synchronization is by using the locks. So how do I use the locks? You have to import threading, and with that threading there you say we saw semaphore. Okay, similarly you have a method called dot lock. Okay, and you just assign it to lock, and you define a function, and in this function you have to write as with lock. With lock means whichever is accessing this function, it will enter into a lock variable, means that is it won't permit the other threads to interfere, and after this job is over, then only other thread can come, it can use this execution. So thread 1 dot thread target is equal to worker, and here target is equal to worker means, see, both the threads are accessing the same function, but since we have used the lock, when one suppose T1 is accessing this function, T2 is not permitted to use this function. So that is the idea of using this lock feature. So you'll be getting worker thread. So once T1 has completed this operation, then only T2 is permitted to access. That is the idea. Now, threads can also communicate each other using a concept of queues. Okay, so how do we use queues means we'll be defining two threads. One is called the producer thread, another is called the consumer thread. What the producer thread will do will, it will add the items to a queue, whereas the consumer thread will remove the items from the queue and it will process. Okay, so now we can see how it is implemented. So import threading. Now you need to import another module called queue. Okay, and you have to create a object for the queue by just giving queue. Okay, then you need to define two functions, producer, consumer. As I told you, the producer will create the add the items to the queue. So how do I add the item means you have to use the method put. Okay, so I am just, what we are doing is we have to create a queue, and you add the elements. That elements is nothing but from 0 to 9. So we are generating using this for loop. So for I in range of 10, q dot put of I. Okay, so this will add to the queue. And you create a consumer function, and where you have to read from the queue, get that item. Okay, so you have to write q dot get. Okay, here no value. Okay, we are getting from the queue, so q dot get, and you store it in a variable item. And we are checking whether that item is present in the queue or not. If item is none, then you have to break. Okay, then you have to print the item. Otherwise, you can print the item. Okay, so this is the functionality of producer and consumer, and you can call those function producer and the consumer. So which will add the items to the queue, and as well as it will read the item from the queue. So like this. Okay, so it is the items added as well as it is read from the consumer. Okay, so you have to use this thread safe data structures like queues and logs whenever this threading is uh, used in the program. And you have to avoid the deadlocks by acquiring the logs in a consistent order. And you can also keep track of execution of the threads by means of logging. So where do you use this multi-threading means it will be used in web scraping. Web scraping means whenever, see, suppose in Google you are searching for some documents, it is searching in different documents to get the results. So each document processing or searching the content in the document can be approached by different threads. And similarly for data processing, when multiple complex data has to be processed, then you can use multiple threads. And for image manipulations also, you can use this multi-threading concept. So it is actually reducing the overhead. Uh, we have to optimize the performance by reducing the overhead produced by minimizing the thread creation and destruction. And you have to perform this load balance by distributing the work among the threads. One thread cannot be overloaded, and whereas the other thread should not be less loaded. And you can also identify some performance bottlenecks. So that is about multi-threading. The main thing is multi-threading can improve the performance and the responsiveness in the Python programs. And you have two approaches to perform parallelism. And thread synchronization and communications are very important for the safe and predictable multi-threading. And debugging multi-threaded programs, you have to pay some attention to synchronization and data sharing. And the real world examples include web scraping, data processing, and the image manipulation. Okay, thank you.